Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the authentication module titled Username Enumeration via Response Timing. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, and then do a search for authentication vulnerabilities and select lab number 5 titled Username Enumeration via Response Timing. Alright, let's get started. This lab is vulnerable to username enumeration using its response times. To solve the lab, enumerate a valid username, brute force this user's password, then access their account page. And then you've got credentials of a regular account, and then you also have candidate usernames and candidate passwords. Alright, so the target goal over here is to enumerate a valid username and then brute force the user's password and access the user's account. Okay, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are being passed in my Burp proxy. I am using the professional version of Burp because we will need to use Intruder, and Intruder functionality is heavily throttled in the Community Edition. Okay, so the first thing I'm going to do is go to my account and then put in a random username that I know does not exist with a random password. Hit login. Let's send this to repeater. Now let's assume that we looked at the response codes and the response lengths and there was no difference. So the next thing to look at is see if there's a difference in timing between an invalid username and a valid username. So let's hit send over here. You could see it took 363 seconds. And if we render over here, it's invalid username or password. Now let's put in a valid username and an invalid password. Hit send. It takes 253 milliseconds, so that's not much of a difference. Let's hit send again. And you could see over here now it's 222 milliseconds. And it looks like the reason was because we got locked out. So it says you have made too many incorrect login attempts. Please try to log in after 30 minutes. So it looks like after about 3 incorrect attempts, it blocks my IP address. Now let's see if it's using a weak blocking mechanism. So we're going to try to see if it accepts the X forwarded for header, which is the de facto standard header for identifying the originating IP address of a request. So what we're going to do is we're going to say 1, which is not really a valid IP address, but let's see if it accepts it. Hit send. And we no longer get the error, but if we try it another 2 times, and we get the error again. So we're going to have to change this, let's say roughly every 2 times in the application for it to work. Okay. So you could see over here, there's not much of a difference between a valid username and an invalid password. And so the next thing that I'm going to try is to increase the password length, because for some applications, they will check if the username is valid first. And if it's not valid, they won't check the password. But if it is valid, they will check the password. And then there might be a time discrepancy between the two. So let's say over here Peter, but then this time around we say Peter, and let's just say it 4 times. Hit send. We get 316, so a little bit bigger than the last time. Let's double it again, and this could be anything, it doesn't really have to be Peter. Hit send. We're at 405, so it increased again after we doubled it. Let's double it again, and this time change the IP address to 3, again, cool IP address, which is not really a valid address. And we've got 655 milliseconds. So every time I increase the password length, it looks like it's doing more computation in the backend, and so it's taking longer for the application to respond. Now let's put an invalid username that I know for sure doesn't exist in the system. So I'm just going to put a bunch of random numbers, hit send. You can see over here it says 239 seconds versus a valid username, which was taking over 600 milliseconds. And the reason is because when it's an invalid username, it's not actually checking the password because it's sees that it's an invalid username, and so there's no use to check the password. But when it is a valid username, it's checking the password. And so this issue in the application allows us to enumerate the list of valid usernames in the application. So let's send this to repeater. And I made a mistake. I actually want to send it to intruder. And intruder, let's clear everything and change this to the username that we know exists. And then highlight it and click add. And then in the payloads list, we want our candidate usernames. So if we go back over here, let's copy all of this. Paste it in here and then click on start attack. So what I'm looking for over here is essentially a time length that is similar to the one with a valid username. However, I'm realizing I made a mistake because I never changed the X forwarded for header. And so you should see over here in the response, it should say that I've made too many requests. So we need to take care of that as well. So let's discard and go to positions and add this one as well. Let's click on add. And instead of sniper, we're going to use pitchfork. So the idea over here is that it'll take in two lists. And then for the first set of payloads, it'll take the first payload in the first list and the first payload in the second list. It'll try that. And then it'll try the second payload in the first list and the second payload in the second list and so on until it reaches the end. That's essentially how pitchfork works. So we're going to go to payloads, and I believe the first one is going to be the numbers. So we're going to have to redo this. The second one is going to be the simple list that we paste over here. And then the first one is just going to be numbers. And let's say it goes from 6 to 106. And we have a step count of 1. So it'll go to 6, 7, 8, 9, 10, and so on. I'm just going to make sure we have the same payload count. It's 101 for both. Okay, this looks good. Let's click on start attack. And now we shouldn't get that lockout message anymore. So you could see over here, if we go to columns and then go to response received and response completed, add them over here, you could see that over here, they all take almost roughly the same response. Let's do a sort on the response time. You can see over here, this one took significantly more than the rest of them. So it's for the username Alaska. So my guess is this is the valid username because it took longer, which means that it actually tried to process the password versus the rest of them, where it didn't try to process the password because it knew that the username was invalid. So I think Alaska is a valid username. So the next step is to close this and then try to brute force passwords. So that would be, we'll remove this over here. We no longer need to brute force it. So Alaska and password would be the candidate passwords. Let's copy that. Go to payloads. And then in the second payload, which it doesn't look like it's selected. Okay, so the reason is because we didn't put a payload over here. So let's say test over here, add it, and then go to payloads. And now we should select the second payload. Let's clear everything and then paste over here. And you can see over here, we've got 100 passwords. And so in our first list, we're just going to change this from 6 to 107 because we already used up those quote unquote IP addresses. And then let's say till 206. So that's a payload of 100, which is the number of passwords that we're going to try. So let's click on start attack. And over here, what I'm looking for is a change in status code, because if we successfully logged in, it should redirect us to the My Account page. And so you should see a 302. And I'm not seeing a 302, which means something is wrong. So if we look over here, it tries in the username and the password and the X forwarded for over here. And again, I'm going to do a sort on the password and it does not work. Okay, let's do a sort on the length. And that looks like it also does not work. I wonder if I spelled this incorrectly, and I did. So it should be Alaska, not Alexa. So let's close this, discard it, go back to positions, and here we go. All right, let's start attack. And again, I'm looking for a 302. And here we go. So we get a 302 on Nicole. So the username is Alaska and the password is Nicole. Now it should have automatically said that we solved the lab, because if you look at the response over here, it redirects us to the My Accounts page. So let's go back to our exercise and just log in using the credentials we just found. So that was Nicole. Hit login. And it tells me I've made too many incorrect attempts because it's still blocking my IP address for 30 minutes. So let's send this to repeater. And in repeater over here, let's just change this to 600. Send a request. Follow redirection. Follow the redirection. And if we reload over here, say test and then test, go to proxy, intercept is on, click login. And then I'm just gonna say Alaska and Nicole, and I'm gonna change it right over here. So let's add the X forwarded for header, and again let's say 777 forward. And did I try 77 already? I don't understand why it's not letting me. Proxy forward HTTP history. Let's go to login. And it doesn't look like it accepted my header, which is weird. Let's do a search on it. Yeah, it did not accept my header. So again, Alaska, and then Nicole, intercept is on. Hit login. And then from there, I'm gonna add the header, X forwarded for, and I'm gonna say 888, hit forward. Okay, this looks like it worked. And here we go. So intercept is off. You could see over here, it allowed us to log in. I guess I just misspelled the header in the last request. And you could see we get congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability using burp intruder. Now we usually script it in Python, but because there was an analysis component that required us to determine how to exploit the vulnerability, which requires a human interaction, we won't be scripting this exercise in Python. In the next lab, we'll look at another case of an authentication vulnerability.